focus primarily on non-functional quality, specifically performance, where we focus on the utilization and latency and availability characteristics of the system under different types of load. And scalability, we ensure that the system is able to maintain those performance characteristics when the workload is growing. And the start of today's show, resiliency, where we also want to maintain and ensure that these performance characteristics are not affected when there are underlying failures. So we subject our systems to failures to see how it is going to react, and those performance characteristics are maintained. This is where we reached out and started working with both Gremlin and Nagarro. And our first step was to figure out what do we need to get started. So we want to build a recommendation engine where once you provide this is what your setup looks like, we could do things like see, oh, I see you have a Mongo with a 3-node cluster. From previous patterns, we have seen that there could be issues here. So we recommend that you do a black hole attack where you take away your primary and see what happens with your election.
Nagarro has built a NREF framework, which is our North Star approach to achieve continuously high resiliency. How do we do it at enterprise scale now? We start with the dev environment. We enable engineers to perform basic reliability tests, example, the instance failures. As the complexity increases, we move towards the QA environments, where we test interdependency and look for cascading faults, and enable teams to test holistically by making game days a habit. The ultimate goal is to test in production and basically come to a point where, to be honest, nothing should be a big deal. Every release can now go through an additional quality gate, a gate that tests resiliency. So with increasing repeatability of these tests, we increase confidence and assurance among stakeholders about the system's ability to deal with unwanted scenarios. For continuous reliability, what we do is we do shift left and add a chaos stage to the pipeline. We have created this shift left accelerator package that has a reference pipeline.
Why is reliability so important? Well, the answer is that modern systems, as I'm sure most of you are familiar with, are incredibly complex. Each bit of added complexity is a new place in the system where failures can occur. Most teams already have a gauntlet of tests built into their pipelines for quality control, especially things like unit tests and regression tests. But what many teams are missing in this step are reliability tests. We have a lot of customers who want to automate reliability in CI/CD, but what many of them find is that this is a lot harder to do than they think. We want to help teams find those reliability risks before they end up even hitting production. So this way, engineers can focus their efforts on where it has the biggest impact, which is, of course, developing products, building features, and scaling services.